Day 2 of 2.6, we're going to continue with doing our proofs. In example 3, we're going to use properties of equality. We're going to prove the property of midpoints. If we know that M is the midpoint of this segment AB, prove that AB is 2 times AM and AM is 1/2 of AB. So the first thing that we're given is that the M is a midpoint of AB. We're going to prove AB equals 2 times AM and AM equals 1/2 AB. So looking at our statements, M is the midpoint of AB. That is my given. I say that AM is congruent to MB. Well, what allows me to say that has to do with the fact that M is a midpoint. When I say M is a midpoint, we automatically know that AM is congruent to MB, and the reason is that's a definition of midpoint. Then I say I go from congruency to equal. So I say two segments are congruent and that their measures are equal. That's the definition of congruency. AM plus MB equals AB. Segment addition. What's happening from statement 4 to statement 5? I see that MB is replaced by AM. So that is substitution. When I do a condensing or expanding, that's your distributive property. So that is what leads me from statement 5 to statement 6. And then to continue to get our part B, what's happening is I am dividing by 2, or the division property of equality. Again, your theorems, postulate sheets certainly will help you in some regard in order to come up with these reasons. What if I look back at example 3, what would be different if you were proving that AB equals 2 times MB and that MB equals 1/2 AB instead? So what's the only difference is I'm using MB instead of AM. So what would you do different? You would just, in the substitution step, substitute MB for AM instead. In this next part here, it's just showing you about writing a 2-column proof. I kind of told you a little bit about that in the last lesson. Again, you have numbered statements based on facts or conclusions, and then the reasons are definitions, postulates, or proven theorems that allow us to state that statement. Okay, so now we're going to look at developing a proof. Again, you're not going to have to worry about this too much. I'm going to pretty much give you the statements. You're going to have to come up with reasons. But this allows you to see what the thought process is behind writing a proof. So we're walking down a hallway at a mall. You notice the music store is halfway between the food court and the shoe store. The shoe store is halfway between the music store and the bookstore. Prove that the distance between the entrances of the food court and music store is the same as the distance between the entrances of the shoe store and the bookstore. It's a lot of words going on, but really the first step is to take those words and draw and label a diagram. So I have a diagram there, basically a series of segments. Then we want to separate the diagrams to show mathematical relationships. Well, it said that the music store was halfway between the food court and the shoe store, so that's represented by the diagram on the left. And then the diagram on the right, it said that the shoe store was halfway between the bookstore and the music store, and that's also the relationship diagrammed on the right. We need to state what is given and what is to be proved for the situation, then write the proof. So I know that B is the midpoint of AC and that C is the midpoint of BD. I'm trying to prove that the distance from the food court to the music store is the same as the distance from the shoe store to the bookstore. So that would be AB equaling CD. All right, so here are our statements. The first statement, again, is my given. AB is congruent to BC. AB is congruent to BC. Looking at that, well, I know that B is a midpoint. So this would be definition of midpoint. I'm going to abbreviate. BC congruent to CD, I have the same thing. Definition of a midpoint. Now I say AB is congruent to CD. Well, if statement 2 and statement 3, then statement 4. If and then, transitive property of what this time? Congruence. And I go from congruence to saying measures are equal. That's the definition of congruence. Does it matter what the actual distances are in order to prove the relationship between A, B, and CD? No, we didn't use numbers. What was the main thing we needed to know? The critical factor is the midpoint. As long as we know about midpoints, we don't need numbers at all. In example 4, there is a clothing store halfway between the music store and the shoe store. So let's indicate that on our diagram. This is the same diagram from prior page. So now we have a clothing store. And I know it is halfway between the music store and the shoe store. What other two store entrances are the same distances from the entrance to the clothing store? Well, didn't we already prove something in the prior lesson, right? So we should be able to, hopefully, without too much thought, be able to determine that the food court and the bookstore would also be the same distance from the clothing store. So how do we write a geometric proof? Well, the first thing we're going to do is draw and label a diagram. Or make sure the diagram provided to you is labeled. Show mathematical relationships in the diagram. So that's anything that's given, make sure it's represented in the diagram. State what is given, and in most cases is already going to be given for you, and what is to be proved. And again, you will be already given that information. And then we're going to write the proof using the given information definitions, theorems, and postulates. And of course, properties would be included. Okay, you want to complete the assignment that corresponds to this lesson.